Okay, on the last video, the last thing we did was finding limits by substitution. You always start by substitution. Now this limit should look familiar. We did this by looking at charts, then we also looked at its graph. So we already know the limit is 6, but let's see what substitution does for us. And so that gives me 3 squared minus 9 over 3 minus 3, 0 over 0. Now this is a limit. This is not a functional value, so we are not going to write undefined or does not exist. 0 over 0 is what's called indeterminate. Right down here, or it's actually it's right here, indeterminate. That this is an indeterminate form, which means we don't know the answer. And so important, when evaluating limits by substitution results in 0 over 0, all this means is that substitution failed as a technique for finding the limit. 0 over 0 as a limit is indeterminate. Indeterminate means that the answer is not easily determined. 0 over 0 as a limit tells you nothing other than to try a different technique. In this class, when 0 over 0 results, when finding limits, try one of the following. Factor, cancel, and substitute. Rationalize as appropriate. Simplify, cancel, and substitute. If the above don't work, try simplifying if possible and see if that helps. So find the limit. Now we already know substitution failed. Substitution yields 0 over 0. All that tells us is to try something else. The obvious something else here is to factor. And factoring is one of those skills we hope you bring with you to the class. And so when I factor, the x minus 3 is obviously cancel, leaving me x plus 3, and then I can substitute. And I should substitute the number I'm supposed to, which is 3. And I get 6, which is what we saw before graphically and what we saw with the chart. So next guy, always substitute first. So plugging a 2 in there. Now you don't necessarily have to show the substitution, but you got to think about it. And so here we have 4 minus 10 plus 6 over 4 minus 4, 0 over 0, substitution failed. All that tells you to do is try something else. If you tell me that 0 over 0 as a limit gives you any answer immediately, that's 0 or that's undefined, you will lose all the points. All 0 over 0 tells you is try something else. And so again, the something else we're going to try is to factor. And so x squared minus 5x plus 6 over x squared minus 2x. And so that's x approaches 2 from the right, of x minus 3, x minus 2. Down below, I can factor out by taking a common factor of x. It's not uncommon for people to tell me that that denominator doesn't factor at all. And so I've got x minus 3 over x for 2 minus 3 over 2 for negative 1/2. Notation-wise, notice I keep writing the limit symbol down until I substitute. Then I write my limit symbol. Now I'm not going to take off if you drop your limit symbol too soon, but there will be problems we do later where if you drop your limit symbol too soon, you might cause yourself to make a mistake. Okay, next guy. Again, substitute first. And so negative 2 plus 2 over the square root of negative 2 squared plus 5, and that minus 3 is not in the radical. And so I've got the square root of 9 minus 3, 0 over 0 again. All that tells me is that substitution failed. So this time, since it's a radical, what will frequently, or square root, what will frequently work is rationalize. Now we also want to recall here that a plus b times a minus b is a squared minus b squared. And what I'm recalling here for you is that when I multiply conjugates, same terms, different signs, they always multiply to the first term squared minus the second term squared. Always. So when I go to do this problem of x plus 2 over the square root of x squared plus 5 minus 3, I'm going to rationalize by multiplying by the conjugate. In the denominator, it is automatically going to be the first term squared minus the second term squared. Now, in the numerator, I could multiply all that out. And it wouldn't be technically wrong, but it wouldn't be helpful. I want whatever is causing the 0 to go away. On all these, all these problems where it's factor and cancel, rationalize and cancel, you want to cancel what's causing the 0. And at least in the numerator, what's causing that 0 is the x plus 2. So I want to leave the x plus 2 alone. And so all I'm going to do in the numerator is write those guys side by side. I don't think I'm going to have enough room here, but we'll try to maybe write a little bit smaller. So now start to simplify and see what you get. So down below, that's going to be x squared plus 5 minus 9. And clearly, x squared plus 5 minus 9 is x squared minus 4. That factors so I have x plus 2, x minus 2. And notice we get the canceling that I wanted. That's why I didn't multiply out the numerator, because I wanted what was causing the 0, and at least in the numerator, what was causing the 0 was that x plus 2. So by leaving the numerator essentially alone, that left the x plus 2 available for canceling. And now I can just plug in. And notice as I plug in, I drop my limit symbol. And what? That's going to be the square root of 9 plus 3 over negative 4, which will be 6 over negative 4, negative 3 halves. And we've got that limit. But that's going to be a frequent technique when we have radicals to rationalize. Okay, the next guy. Again, substitute. And so I'm going to have 1/2 minus 1/2 over 2 minus 2. 0 over 0. Substitution failed. And again, you don't have to show that step, but you always have to think about it. Now what we're going to do here is we're going to we're going to simplify this guy. And so we're going to simplify by multiplying all terms by 2x. Which is the common denominator of the 1 over x and 1/2. So the limit as x approaches 2 of 1 over x minus 1/2 all over x minus 2. And so I'm going to multiply everybody by 2x, 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 2x. And technically it's 2x over 1, so you're lining up numerators. So I get to cancel. And so I've got some canceling there. And so I've got the limit as x approaches 2 of 2. The 2's cancel there, minus x. And that'd be 2x squared minus 4x. And then you could substitute. And you're going to get 2 minus 2 over 2 times 2 squared minus 4 times 2, which is going to be 0 over 0 still. So substitution's still not working. But now I can factor. And so I sort of did a step that I probably didn't really need to do, that I can now factor out that denominator by factoring out that 2x. So I multiplied everybody by 2x, which wasn't wrong, but now I have to go back and factor it. So I kind of had a little extra step that maybe I didn't need, but that's okay. And then these guys cancel, but those are opposites. And so because they're opposites, they do cancel, leaving behind a -1. Remember, canceling is just division. And when you divide opposites, 3 divided by -3, the answer is -1. And now I can substitute and get -1/4. And this is where we will conclude this video.